Hello, and this time we're constructing equations. And this is probably the most realistic aspect of algebra in a day-to-day life, where you have some sort of problem. It might not be explicitly got algebra in it like this. It might be more worded in this sense, or not even words at all. It might just be the kind of problem where you have an unknown and you don't know what it should be, and you can either sort of trial and error slowly find a solution, or it might be that if you have this skill, you can construct it into an algebraic equation and then find the answer very quickly. So obviously these examples are quite contrived in a maths textbook or an exam to elicit that skill from you. But it is something that if you can think in the right way, it's useful to try and remember that skill beyond exams, that sometimes a solution will be found by carefully rewriting the question into something that's easier to solve rather than just having to guess all the time. So here's two examples. And what we have here, it says the areas of these rectangles are equal. Sometimes it might say that the perimeters are the same or the volumes are the same. In this case, the areas are the same. And so you have to just stop and think, okay, well, what if this had numbers? How would I work out the area of this if it actually had numbers? Well, I would do that length times that length. And there's nothing stopping you doing that, but doing it with the algebra. So you'd say, well, the 6 times by this thing, the 3x plus 2, is timesing the two things together. That would be the area of this one. And this will give you the same amount, because they're equal, as the area of this one, which is again timesing the two things together. That's the thinking part done. This is the sort of turning the application where we're talking about areas, and we've now turned it into an equation. This could represent anything now. In fact, it still represents this as great, but it's just a load of numbers and letters now. And we solve this in exactly the same way we'd solve any other equation. Probably the best thing to do here is to multiply out the brackets, although you don't have to, but multiply out the brackets. So you get 18x plus 12 equals 60 minus 6x. Move the x over, so that's going to give us 24x. Move the 12 over, doing the opposite, so that's going to give us 48, and then divide by that, and we get the answer of x equals 2. Now, that doesn't answer the question. You've got to be careful with these. We've worked out what x is. We wanted to find the dimensions of each rectangle. So this is 6 times 6 wide, and how long is it? That's 2, so it's 3 times 2 plus 2. We worked out the x value, but we wanted the dimension of the box. So that's 8. 3 2's plus 2. And this one is too tall. How long is it? Well, 3 times 2 is 6. It's 24 long. 30 takes 6 to get those dimensions. So make sure with these questions that you do read the question. Is it asking for x, or does it want something back in the application? So having turned it into an algebraic equation, solving in a very pure sense, you've got to turn it back and work out actually what it's asked for. Now these, the second example here, slightly trickier. You have to really think about how you're going to work out the answer, and sometimes you've got to do it in two stages. But anyway, let's have a read of this one. My sister is 4 years younger than me. The sum of our ages is equal to my age in 10 years. How old am I? So let's start writing some things down in terms of each other. So my sister is 4 years younger than me. And it wants to know how old I am, so let's stay with me. The me person. So let's say the age of the me person is A. And my sister is 4 years younger than me. So the sister is A minus 4. The sum of our ages, which is adding these two things together, my age and the sister's age, the sum of our ages is equal sign, to my age in 10 years. Well, my age at the moment is A. In 10 years, I'll be A plus 10. How old am I now? Well, again, now I've sort of done the thinking and I've written down each stage and thought, what how can I describe each of these things in the same terms, the same sort of in comparison to the me character's age currently. Now all these A's are the same, they're the me character's age right now, but this is a correct statement that they've said here, that adding the two ages, the sum means to add them together, is equal to the age in 10 years. Now I can just solve it. A plus A is 2A minus 4 equals A plus 10. Take the A away from both sides to get A, add the 4 to both sides. That means the me character is 14 years old. The tricky thing with these questions is not the solving bit. That's okay. It's constructing it in the first place. It's sort of taking the idea, and sometimes you just have to stop and think, okay, ignore what it says that's got algebra. How would I do this if it had numbers? If you've got buses and you're trying to work out how many buses you need for a certain amount of people, and it's sort of like M people and how many buses you need. Well, just stop and think, if it was 100 people, how would I work out how many buses it would be? Well, if each bus can take 32, I'd do 100 divided by 32, and that would tell me how many buses I'd need. Obviously, you'd have to round up, so you had the right number. You need that last bus for the decimal amount. So if you've got M number of people, you do the same thing. You do how many people, I don't know if I said 32 people on a bus, 100 people in total, so 100 people divided by 32 on each bus. Well, if it's M number of people, you still just divide it by 32 to see how many buses it is. So in all these situations, it might work to sort of think, okay, if I knew what this was, if I knew this was 10, how would I work out the area? 6 times 10. Well, I'll do the same, but with the algebra. 6 times that length, and write it down. And for these questions, you just got to try and pick one term, one variable, like the me person's age, and then describe everything else in terms of that. So the sister's age in terms of A, the age in 10 years in terms of A, and then you can follow those instructions to say what is equal to what. The sum is equal to that age in the future. Once you've got it written out, though, once you've constructed it, then you're back to just solving, which if you're not able to do that, well, that's another video. Anyway, any questions that you might have, pop them in the comments. But if not, then ta-ra for now.